viewers, you are welcome to my class. Today's class will be based on isotopes. Then what are isotopes? I'm going to use these two elements to define isotopes. When we look at the two elements, they are atoms of the same element. They are the same element with the same atomic number. The number down is called atomic number. So they have the same atomic number. Then the number up is called the mass number. Mass number. So they have different mass number and the same atomic number. So when you have two or more elements of the same atomic number with different mass number, we say those elements are isotopic in nature. So let's define isotope. Let's define isotope. They are atoms of the same element. Isotopes are atoms of the same element with the same atomic number but different mass number. Let's take it again. Isotopes are atoms of the same element. They are the same element with the same atomic number but different mass number. So let's solve this question on isotope. Isotopes of element X are the mass number of 18 and the other one with mass number of 16 in the proportion of 10% and 90% respectively. Calculate the relative atomic mass of X. So let's write the first one, the first element with mass number of 18, then atomic number of 8. So it has what? A relative abundance of 10% or the percentage by mass of 10%. So the first one with 10%, then the second element has a mass number of 16 and atomic number of 8. So the percentage by mass of the second element is 90 with 90%. With 90%. So the two elements are isotopic in nature. Why? Because they have the same atomic number with different mass number. So they are isotopic in nature. So we are looking for the relative atomic mass. Now to calculate the relative atomic mass, relative atomic mass will be equal to the percentage by mass of element X, the first element, plus the percentage by mass of the second element. So let's call it element 2, X2. The first one will be X1. Then the second one will be X2. X2. Now, what is the percentage by mass of the first element? That is 10%. 10% of the mass number by mass. So what is the mass of the first element? That is 18 plus the percentage by mass of the second element. That would be 90% of the mass of the second element is 16. Don't forget that the number up is the mass number. So the mass number of the second element is what? Is 16. So our relative atomic mass will now be equal to 10% means 10 over 100. Then off we change to times 18. Then plus 90% means 90 over 100. Off means 10, so times the mass number of the second element times 16. So which is equal to, this 0 we cancel 0. So this one will give us 18 over 10. 18 divided by 10, then plus this one cancel this. So 9 times 16 will give us 144. 144 divided by 10. So which is equal to 18 divided by 10 will give us 1.8 plus 144 divided by 10 will give us 14.4. So 14.4 plus 1.8 will give us 16.2. So the relative abundance of element X will be 16. So let's solve question 2 on isotope. An element X with relative atomic mass of 16.2. We have the relative atomic mass equal to 16.2. Contains isotopes. So the first isotope with the mass number of 35. The first isotope with mass number of 35 and atomic number of 17 with relative abundance of 10%. That is, the relative abundance of the first isotope is 10% of 10%. Then and another isotope, the second isotope with the mass number of m. So our m is unknown here. So the second isotope with the mass number of m and the atomic number of 17 has a relative abundance of 90%. So that is, this second isotope, the relative abundance is what? Is 90% of 90%. What is the value of m? We are looking for the value of m, that is the atomic mass or the mass number of the second isotope. So we are looking for the value of m. So our m is unknown. Now, to calculate relative atomic mass equal to the percentage by mass of the first element plus the percentage by mass of the second element. Percentage by mass of the first element plus the percentage by mass of the second element. Then what is the percentage by mass of the first element? The percentage by mass of the first element is 10%. So our relative atomic mass is given, which is 16.2. So we are going to say 16.2, that is relative atomic mass, equal to the percentage by mass of the first element, that is 10%. 10% means 10 over 100 of the mass number. So the mass number is what? Is 35 of the first element times 35 plus the percentage by mass of the second element. The percentage of the second element is 90%. That will be 90 over 100. So 90% means 90 over 100. So multiply by the mass of the second element. So the mass of the second element is m. Don't forget that the number up is the mass. So the mass of the second element is m times m. Now, 0 cancel 0. This 0 will cancel this 0. So this one will give us 16.2 equal to, this one remain 35. That will be 35 over 10 plus 9 times m will give us 9m divided by 10. So 16.2. Then we give us what? 35 divided by 10 will give us 3.5. 3.5 then plus 9 divided by 10 will give us 0.9. So it's 0.9 what? M. So we are going to collect the like terms to get the value of m. So this one will give us 16.2. Bring 3.5 to this side. That will be minus 3.5 equal to 0.9 m. So therefore, 16.2 minus 3.5 will give us 12.7. So 12.7 equal to 0.9 m. So we are looking for the value of m. So you divide both sides by 0.9. So divide this side by 0.9. So 0.9 will cancel 0.9. So our m will now be equal to, so 12.7 divided by 0.9 will give us 14.1. So the value of m, that is the atomic mass or the mass number of m from these elements 2, from the second element is what? Is 14.1. So let's solve one more question on this topic. So let's solve the third question on isotope. This one is different from the two questions that we have solved. So the question says that two isotopes of Z with mass number of 18 and 20. Two isotopes of Z. We have two isotopes of Z. The first one with mass number of 18. The second one with mass number of 20 are in the ratio 1 to 2. This ratio means the number of atoms. So when you say 1 plus 2, it will give you 3 atoms. So it shows that this element Z consists of 3 atoms. One atom has a mass number of 18 and the second atom has a mass number of 20. So one atom of Z has a mass number of 18. Then 2 atoms, the second ratio will be 2 atoms. The first one is 1 atom. 1 atom of Z has a mass number of 18. Then the second ratio means 2 atoms. 2 atoms of Z has a mass number of 20. So what will be the relative abundance of the first atom? That will be 1 times 18 will give you 18. So the abundance of the second atom will be 2 times 20 will give us 40. So what is the total abundance? We are going to calculate the total abundance. This one will give us 8. This one will give us 5. So this is the total abundance. Total abundance equal to 58. So that is the total abundance. Now to calculate, we are looking for determine the relative atomic mass. To calculate the relative atomic mass, so we are going to say total abundance so divided by the total number of atoms divided by the total ratio. Don't forget that the total ratio is the total number of atoms. So our relative atomic mass will now be equal to, so what is our total abundance? That is 58. It will be 58 divided by, the total ratio is 1 plus 2. So which is equal to 58. Our relative atomic mass will now be equal to 58 divided by 3 will give us 19.3. So the relative atomic mass is equal to 19.